this computer. Hey everyone. So today is going to be the start of the second general meeting for the CLE 2024 group as part of the Data Science at Georgia Tech Club. This meeting is going to be themed around data preprocessing and exploratory data analyses, so EDA. And hopefully this is a good milestone meeting that everyone can share kind of some of the results that they've been doing over the last month. Before we jump into the main meat of this meeting, I'd like to go over some admin things. So give me some time to figure out how to share my screen. Share screen. Okay, can everyone see this?
Yes.
Yes.
Great. So these are the meeting notes. It's pretty easy to find through the index. So I'll go over some admin points. So we have some points about infrastructure, the mailing lists, and team changes, as well as the expo that's coming up, or is tentatively planned. So first is all the infrastructure stuff should be set up at this point. So we have various groups. We have a GitHub organization. We have a mailing list for the calendar invites and the VM alerts. And we have some ACL groups for editing any of the documents in the Google Drive or accessing the VMs to GCP. If you are on a team and you don't have access to any of these resources, you can feel free to reach out to your team lead, and they should be able to add you to any of those lists. And you'll know if you don't have access because you won't be able to do things. Next is onboarding videos. So in the infrastructure, we've tried to set up some onboarding videos so that you can figure out how to get started with those VMs. So Murillo recorded a video on how to SSH into a VM, how to turn on a VM, how to SSH into it, how to use VS Code to start a notebook. And so this is a good place to start. We have an associated Markdown document that everyone can contribute to. So if there are weird idiosyncrasies with the setup, then you can add it there. And I'd encourage people to contribute knowledge into a centralized place. So it is editable by everyone. The second is just a video that I added when going through some of the VMs. So there's some stuff on adding a GPU to your instance, resizing disks, which is a thing that probably many teams will have to do when they start using these machines. And then the last point in the infrastructure piece is let me move this just a few out of the way. The last thing here is billing for January. So the bill for January was $62.07, and I get a billing report every month. I have done a pretty good job at tagging all the resources, so we can get a breakdown of who's using what. I think birdclef ended up using most of a larger portion than others because we had the machine on and we also had a GPU attached. But this is something that I will report every month just for transparency. And I've iterated this many times, but I'm more than happy to facilitate infrastructure and compute because I want to make it a good environment for everyone to be able to do research and to contribute to this competition. That being said, multiple people have asked me how they can help contribute to the bills. And so if you want to help, feel free to Venmo me, PayPal me, or use Ko-Fi, which is PayPal. This is linked in the index, and happy to take whatever amount that you want to donate. But otherwise, I'm expecting to foot a majority of the bill. Hoping birdclef gets us a little bit of prize money, which would help significantly. So that's it for infrastructure. Any questions? Cool. I'll move on to the next point then. So the next point is we have a set of mailing list threads. So you might have seen this in your Georgia Tech email, but this is basically a weekly thread that will get started where teams can contribute a couple of data points, or they can contribute a summary of the things that have been going on with their team. And I think this is a good way to cross-pollinate between our teams, since we only meet once a month as a broader group. So I've been trying to put in summaries every week. This last week I didn't, and this is a new thing. So I think maybe this next time we might change the cadence. So we do one every other week. So one for this meeting, one for kind of the midpoint to the next meeting, and then one for the meeting after. So we'll see how that goes. I'm hoping to use these mailing list threads as a way to consolidate all of the updates into one document instead of treading through all 11 notes documents. So please contribute to the mailing list threads. Hopefully people find them interesting, or at least have a sense that other people are working through challenging problems like everyone else. So that's the mailing list threads. Anyone have questions there? All right. The next point is a few team changes since the last meeting. So there's two, one for bioasq and one for longeval. So we've had a change in leadership for bioasq. So Jen, who was leading bioasq kind of through the end of last semester to the beginning of this semester, has left, and Wenshin is going to be the new lead for bioasq, and she's been doing some great work with that team. Wenshin, would you like to introduce yourself?
Hi everyone. So I am in OMSCS program. It's my last semester now. I've done all the courses. I just need to graduate. So yeah, I'm pretty interested in doing research, and think this is a great group, and to try to do some competition and start with a short research paper. Yeah, so I'm a software engineer for 4 years now. I'm working on a data storage company. And my day-to-day job is mostly related to file system development, writing C++ code. And that's it for me. Nice meeting everyone.
Thanks, Wenshin. So yeah, look forward to her update later in this meeting. The next person I'd like to introduce is Joshua, who's going to be leading a new team for longeval. Joshua, do you like to introduce yourself?
Hi everyone. Yeah, I'm Joshua. This is my first semester of OMSCS, but I've done some research at undergrad, so I was really excited to see if I could take on this opportunity. Yeah, my day job is a cloud engineer at Oracle. So having a lot of fun working around GCP, going back and forth from OCI to GCP. And yeah, I'm excited to kind of get this on the road and get hopefully get a win.
Awesome. Thank you, Joshua. Yeah, I'm glad you decided to step up to the plate, and I think longeval will be an interesting competition. So also look forward to Joshua's presentation later in today's meeting. The last bullet point I wanted to bring up before we go into the presentation itself is the data science at Georgia Tech organization will have a project showcase probably later in the semester. There's not a lot of details. I'll ask about it when I do my meeting with the director for projects. But if you're on campus, then consider maybe joining this expo. I'll try to find out if there will be ways for online students to be able to participate in that expo, but It's always a good opportunity. It's always good to try to present the work that you do. So this is one of the opportunities for people on campus to kind of talk in this broader community of other students who are interested in data science. So I'd highly recommend participating if you're attached to one of the groups and are on campus. So that is the end of the admin section. Any questions? Cool. So let's go on to our milestone presentations. Let me figure out the slideshow. This is not what I want. Interview. Okay. Share my screen. Can everyone see this?
Yes.
Yes. Okay. Okay, so this is our milestone presentations for all the teams. And again, this is the Data Science at Georgia Tech CLE 2024 group. Today's theme is all about data preprocessing and EDA, although some teams haven't had the data come out yet. So it's really an update for everything that's happened since last month. So the outline for today's presentations will go through a very brief introduction, and then we'll go straight into the team milestone presentations. We'll talk a little bit about what next week will be about, and we'll have some time for questions and discussion afterwards. So what is data preprocessing? What is data processing, and what is EDA? I think there are three big challenges with most of the lab competitions in CLE 2024, or CLE in general. So it's an information retrieval focused competition. And one side effect of being a very heavy systems evaluation focused conference is that these tend to have larger data sets. And the data is on all sorts of different formats. So I've outlined three problems that we might have to face and three problems that I expect most of the teams have to deal with. The first is that it can be challenging to download the data. There have been tons of teams who have said, emailed to figure out when data sets are going to be available. These data sets can be really big. Geolifeclef, for example, is roughly 70 gigs of data. I think touche is supposed to be like a terabyte of data. So there's some data sets that are super tiny. So there's lots of different sizes of data. And they come from weird locations. Like I think erisk is distributed on an FTP server. You have some data sets that are hosted on Kaggle. You have some data sets that are hosted on a custom like NFS type thing. So downloading the data can be hard. The second thing is loading the data. So CLE is a multimodal conference. There's lots of different modes of data. So there are XML files that represent structured data. There are audio files. There are lots of images. There's lots of text. And there's lots of different structures and naming conventions to all these data sets. So just loading the data can be a challenge of itself. And the final thing is that understanding the data is really the first step towards building a good model. What is the structure of the data and the schemas? What are the distribution of data points in the data set? And what basic statistics can you derive by just flipping through some of the data sets? So I'm hoping that today we can all kind of get a rough idea of what everyone's data looks like, and maybe some really basic insights that we've gleaned. So we'll go straight into it. So birdclef is the competition for bird call classification. And this requires building a model to identify when there's a bird call in a long audio soundscape. So there might be hours and hours of audio. We want to find the bird calls, and we want to identify what bird calls they are. So as a team, we've been doing a few things. We've gotten the data from the previous year competition because this year's competition is not open yet. We've had Adrian, who's been researching models, Ashley, who's been looking at a model that she'll be presenting, Rusty, who's been working with Mixit for sound separation, and Murillo looking at some species imbalance. So I'd like to ask Ashley to present a little bit about the vocalization model. Ashley?
Cool. All right, I'll just tell you when to move slides then. So I did a bit of research into the Google's bird vocalization model. So I tested the model on birdsong and bird audio without noise, and I tested the model on birdsong or bird audio with noise. So then I'll talk about we can swap slides. What Google's bird vocalization model is. It's trained on Xenocanto recordings. So Xenocanto is a database of wildlife sounds. And so scientists and like people from all over the world will collect sounds, but we're specifically using bird vocalizations or bird song. This model gives output logics on more than 10,000 bird species and also creates embedding vectors that can be used for other tasks. It uses a variety of different data sets. Some are open source, some are not. High Sierra, sapsucker woods, just from different places all around the world. Some of them have noise and some of them don't. So it's a pretty good variety of different bird sounds. Just to briefly go over metrics. Next slide. So MAP is the mean average precision. It's computed per example and it's subject to class imbalance. And then there's also a CMAP5. So it's map like per class. It's a mean average precision per class. And then it averages over the classes. And there's also an accuracy metric that computes the accuracy of the highest logit per example. So the reason why I talked about this is because in the next slide, there's per data set. If we look at the first two columns, the first three columns, they show you like different statistics per data set that they used. So the mean average precision per class is highest for the High Sierras. But then if you look at the top, like the highest amount of accuracy, you can see that Powder Mills data set has the highest. So I decided to test this model on birdsong with and without noise. So first I tested it without noise. And so I uploaded several birdsong clips from Wikipedia and Xenocanto's grade A and B. The model is really accurate. This is just an example of a birdsong from Wikipedia. And you can see that with it was about 35 seconds. So, and I split it up into like 5 second portions. And you can see that it has an accuracy of like 99.99% per. So it's pretty accurate in detecting Canada gooses. But Canada geese, I feel like they have a really distinct sound. So then I tried with noise. And Xenocanto, the wildlife database, has different different grades for how good or bad a recording is. It's from A through E. So E is really bad. Basically, there's like a lot of wind, there's a lot of environmental sound, but there's still a bird sound and humans can distinguish it, but we wanted to see if a machine learning model could. It's not that accurate. If you see that it misidentified this pinion jay, who's at the top, with all these other birds, which are Eurasian curlews, black-billed magpies, goldcrest on the bottom. And you can also see the probability on this side is also not very high. So we can, some of them even misidentified with a high accuracy, if you look at frame 5. So that wasn't too good. Then I tried another one with noise, just to show you like a shorter clip. And it also is not that accurate. It misidentified this gray plover as a European goldfish and tawny owl. But then I tried starting from grade D though, there was a 95 to 99% accuracy. So if you look at Hume's warbler or little winged proble, you can see that plover, you can see that there's a, it's kind of small, but 99, 98, 97, 95% accuracy. So starting from class D, I felt like I noticed just from handpicking recordings and testing them that this model was pretty accurate. I guess there are next steps. I also tried just with an environmental sound database, but it just classified, it didn't distinguish between what was a bird sound and what was not a bird sound. It just classified all sounds as a type of bird. So that was the EDA I did on Google's bird vocalization model, and I'll pass it on to, I think next one is geolifeclef.
Thank you, Ashley. next is, geolifeclef. And for this, I'll pass things to Mark, who will talk a little bit about the data used in this competition. Mark?
Hi, how's it going? So yeah, this competition is basically taking a bunch of data that has composition of plant species over a time interval and location, and using them to predict the change in composition of plants. And the bulk of this data that we're given is presented in geotiff format. And you see, obviously, it's a lot of data and a lot to deal with. But it's important that we have this format because the visual representation in our training data is kind of the forefront of everything. Locality is really important for every relationship we're going to derive from it. And here's an example of what that roster data looks like, just span across Europe. Next, so here's an example of how you can measure this. So x-axis here is longitude, y-axis is latitude, and the elevation is shown on a color scale with the metric there. And next. So the kind of most important data in our model is the presence only and presence absence data of the life species. And this has a species composition, and the presence only is basically where it's recorded. And so here's just kind of the data sources that these are all pulled from and collected over time. And in these attributes are time series, ID, and geolocation allows for linking between this and the roster data shown before. And the presence absence data that goes along with it is more just for supplementary purposes, and this compensates for the false absence issues in the presence only data. And there's over 10,000 different species covered. So the pre-processing of this data is we take these satellite images and they have to be converted to what they call tiles. And so we need to cut everything into a defined resolution and size to be able to process it correctly. So everything has to be the same. This is an example of the satellite image taken into tiles. And I think these are 256 by 256 pixels of what they're cut into. So each tile has this unique storage scheme that consists of a coordinate system origin, a zoom level, a pixel size, and a shape that we'll all keep standard across the whole tiling process. And I'll hand it over to you, Anthony, if you want to talk more about image patches.
Yeah, thanks, Mark. So Mark's given really good context on why we might store data in images. And there's one piece of this competition where we're given many of these images. We have 4 million image patches that correspond to some of the presence only labels. And one way to pre-process this data for the embedding model that we want to use downstream is to put them all into one data set with the metadata associated with it. So we're going to read all these. We haven't done this yet, but we're going to read all the images into memory. We're going to extract some of the geolocation information and year information in it. And there's a very specific sampling methodology that they use in this tile to vec paper, which is a way to convert images into a vector space where the vector space represents distance. It preserves distances between individual tiles. So what we want to do is we want to sample from this data set 2 tiles that are really close to each other and 1 tile that's really far from each other, and to build these triplets so that we can do this representation learning for the data. There's a couple of interesting things about the patches, is because they include both the year and month, presumably, and the actual patches. So I think there's going to be some interesting spatial temporal sampling that needs to be done here. But anyways, this is it for geolifeclef. Next is plantclef. So I'll hand things off to Murillo.
Hey, hi everybody. So I'll be talking about the plantclef. I'm just gonna go over very quickly about this slide because last time we met, I already talked about this stuff. So if you don't already know, plantclef is gonna be a multi-label classification task, and it's gonna be for images, so images of plants. So the original challenge had 80,000 species and 4 million images, which is about 250 gigabytes of data. And there has been an update on the competition this year where they actually decrease the number of images to 1 million images over 15,000 species. I believe they're going to be mostly on the European continent. And also is going to be over 62 gigabytes of data. The main challenges of this is going to be the test set's going to be significantly different than the training set, specifically because the training set is going to be a single labeled image, and the test set is going to actually be a multi-label task. So it's going to be a little tricky to convert from a single label to multi-label. And also the evaluation is going to be on the test set, so it's going to be on the ability to predict all plant species in a single image. So next slide. Just to, I guess, highlight how difficult this problem is. So this image actually shows a really big intra-class variation of a single species of plant. So all of those images belong to the same species. As you can see, there's different multi-scales and different backgrounds and even growth stages of plants. So it's a very, very difficult problem to tackle. So yeah, next. Okay, so the work that we have been doing thus far, so the data set has not been published yet, but we've been mainly doing work for the snakeclef competition since their approach is going to be very similar to ours. So we were able to create two scripts, a bash script and a Python script. The bash script automates the process of downloading and extracting all of the images from GCS and mounting them locally. And the Python script converts all of the images into binary data, writes those to a data frame, merges them to the metadata respective to the dataset, and also outputs that data frame as a Parquet file to GCS. So I also wrote a notebook because all of those two scripts, they support customized paths. So like, we can use them for snakeclef, but also we can use for plantclef and perhaps even fungiclef. So it supports that customization, so you can very easily switch the paths and the variables into the scripts, and you can download and create those Parquet files very easily. And yeah, that's mainly the work that we've been doing. And perhaps next time I can talk more about the methodology and the approaches that we're going to be doing moving forward.
Thanks, Morello. Next, we have snakeclef. So for snakeclef, I'd like to ask Austin to talk. Austin?
Awesome, thanks. Do you think you could reload it? Actually, I just added a couple more images on following slides to this.
Yeah, let's see. Presenter view.
Okay, awesome. Yeah, so for snakeclef here, you heard from Marilla there, we're kind of working hand in hand at this point on some of the pre-processing steps, getting data kind of loaded up in the right systems. So I'm going to give an overview of just kind of the task by itself, and then also some of the embedding explorations that I've been working on in the snakeclef domain. So firstly, this is the challenge here is to classify. It's a single label for the whole image. So in that way, it's easier than some of the other ones. But as you can see from these images, finding the actual snake in the pictures is not trivial at all. It's some of them, it's entirely unclear to me, even where the snakes are, like the top right there. So yeah, some of these, the question is going to be, how do we make sure that as we're going through creating embeddings for these images, how do we make sure that it's mostly focusing on the snakes rather than the plants or the ground or whatever is in the picture? So that's going to be a topic that we're going to keep exploring as we go on. But right now I can talk about some of the first things that we have here. So this one is kind of our leading model. We're kind of assuming this is going to be pretty important for us. This model is called Dino V2. It was trained by Meta as a kind of general foundation model for vision. The way that they did it was they essentially created a self-supervised training method, kind of similar to, inspired by LLM training of like ChatGPT and all that. So the idea is to essentially give it tons of images and have it kind of be semantically aware of what objects are in the images, and then mask little parts of it and help it essentially make guesses about what was in those masks and teach itself just iteratively. You don't have to give it too much labeling. It's able to learn some basic features for each of these images. So from this one, you can see the outputs of those. Yeah, so we have a couple images here. These are from our data set. They came in of various sizes. And then the right is you see the output tensors from DynoV2. So some interesting notes here are that the output sizes are all the same. So you get these, like on the input, you got 135 by 240. It came out to 257 by 760. The other image is shaped differently. It's shaped vertically oriented, but the output tensor is also the same. So the fact that these are able to map into the same tensor space, the same vector space coming out of this means that we can kind of use these images, use these tensors that are coming out of it to be able to model, hopefully, and have it find common areas within those tensors that are relevant towards the images. As you can see, just by visualizing those as well, they're not super informative, those visualizations, but it does seem that the vertical axis is essentially where the features can be more oriented towards. So it's worth noting that there's probably some correlation there where these dyno images, we're going to try to use that axis of the image in tandem with each other. Anyways, there's a couple other ideas. I've been just kind of exploring these ones to make sure that we have a good foundation. If we do find that our images are not really classifying well, I think one obvious way might be that it just doesn't recognize the snakes, that we're classifying the rocks or the plants, trying to guess the snake type or the snake species by what rocks or plants are around it, which is obviously less informative than if we actually had a model that was aware of which object was the snake and then making determinations about the snake based on its features individually. So two models I've tried here are zero-shot models. This is not something I necessarily expect to be able to scale well, just because zero-shot is not going to be as good as train models in this case. But the two options here are segment anything model by Facebook, which is interesting. It's able to essentially take any models. So you see the left side there, take any picture and break it up into various segments. So you see the far left picture has been run where essentially the model was allowed to make as many segments as it thought was relevant. It places like 700 or some individual pointers on the map and then figures out if it belongs to the same segment or different segment than the other ones. So from that, I got all of the masks that were present on the left one, and then I just filtered it down for the second largest mask to produce the one on the right. Obviously, that's not a repeatable workflow. You don't know if it's going to be the biggest mask or the third biggest mask or anything like that. But it does kind of show essentially what the model is doing, and the mask it's available inside of those weights. It's just something that needs to be retrieved. The other model is Alvi, or I guess Alvit. I would pronounce it that way. This is a zero-shot modeled by Facebook, where you can essentially provide a text prompt to the image as well, and it will return what it thinks is the relevant object there. I got about a 50% success rate with this, giving it the word snake and just having it pick out where a snake was. And it wasn't always obvious why it didn't get it. So the pictures on the right here, actually, I tried to give it a bunch of different snake names, hoping that it would be trained on various snakes and maybe it would return more of them. It still came about 50, giving it all those names versus just giving it the word snake. And like the one on the left, I don't know if it maybe thought it was a worm or if it just, yeah, for me, like some of them seemed like obvious it would be able to see it, but it didn't necessarily pull that out. So it could be a way to create a training set if needed, but that's something I can keep talking about in the next slide as well. So being able to train a classifier to either detect bounding boxes or image segments is another option here. And so if you have a good enough labeled data set, you can train a classifier like YOLO V8 is pretty good at this task to identify the specific object that you're looking for in images. So I did find this site called RoboFlow, which is a great platform for computer vision training. It essentially has all these labeled data sets that people have created, and it gives them tools to build these, but it also, unless they have a pro subscription, they need to make their data sets public for everybody to access. So there's a bunch of like 1,000, 3,000, even some 7,000 size image data sets out there with the snakes labeled in each one. You can see examples of those labels there where they have the actual image segment itself. label of the snake. So being able to train a model using that data set, which is open source, could allow us to then pick out where exactly a snake is in each picture with some degree of accuracy. And hopefully in that case, if we come to the point to make sure that our model is only looking at that snake, that will allow us to kind of zoom in on that capability. Yeah, I think that's it for me.
Awesome. Thank you, Austin. Super interesting to see some of the potential directions for snakeclef. Next will be fungiclef. So Chris put together these slides, but I will be presenting because Asia, Europe, US time zones are very tricky. So fungiclef is a competition that is very similar to snakeclef, but this is for fungus. So we're looking for poisonous versus edible mushrooms. This data set has about 300,000 images, and it also has this interesting metric that focuses on whether a mushroom is poisonous or not. So there's these two mushrooms here that look almost identical, but one is lethal and the other isn't. So there are very practical applications for being able to identify visually whether a species is going to be poisonous or not, whether it's snakes or fungus. So here's a selection of different species and families of species. They look many of them look very similar. And so this idea of being able to automate the identification of species like this is very challenging. So what we've done so far is we've come down with a development data set that is basically a subset of all the species in the set of images that we have. So we have 6 classes that cover most of the most common families. There are 5 poisonous, or there are 5 non-poisonous classes and 1 poisonous class. And there are species that are very similar to each other and species that are very different from each other. So we're hoping that this development set is enough data to capture the kinds of intricacies that the competition is focused towards, as well as being small enough to work on a local machine and to do development in a reasonable way. There are probably going to be like smaller test sets that we can use to just validate pipelines. But we have now a set of species that we can use to kind of model with and to tinker with. So some of the next to-dos are to actually build a baseline model. We're hoping by the next time we have this meeting, we'll have our name on the leaderboard somewhere. It doesn't have to be just on the leaderboard. And we'll explore more into modeling for pre-trained models from previous competitions, as well as ways that we can improve that baseline. So the next presentation will be from bioasq. So Wenxin, can you present?
Yeah, so for bioasq, we have 4 tasks: synergy, bioasq, 12B, bioNE, and NER. So the last 2 are related to NIM entity recognition. They haven't published the data set, so our current focus is on the first 2. So there are 2 phases of the first 2 tasks. One is information retrieval, the other is question answering. So can we go to the next slide? Okay, so for the synergy and the bioasq 12B, the data set we have is this question answering data set, which I think the organizer developed over 10 years from the competition, and for every year they created probably like 300 new questions and added to this data set. So now they have 5,000 questions and answers in total in this data set. And there are 4 types of questions here. There's yes or no question, where you're expected to answer yes or no to the question. And then list and factoid questions are question where you need to return an named entity, a medical named entity as the exact answer. And then for audience, we also need to return an ideal answer for those questions, which is answering the question in more context, giving a few sentences to expand the reasoning or just expand the background of the question. And the next slide. So the data format of this QA data set is we have the question, and then the documents and the snippets are information we need to retrieve from this website called PubMed. So we need to be able to find the related documents from PubMed and return it as the results for the document and snippets. And in addition, we have to return an ideal answer, which looks like this, and then a few sentences, and then exact answer, which is a list of a list of strings. So on the right side is what it looks like for one article in PubMed. So the PubMed ID is what we need to return in the document, and then we need to select the snippets from this document, which happens to be in the conclusion part for this question. So next slide. So we now talk about the PubMed dataset. So PubMed is a search engine which for a dataset which contains abstracts and titles for biomedical literatures. It's a huge dataset. It has more than 24 million records in 2016. Now it's definitely much more than that, and it takes more than 100 gig of storage to get this data, and this data is stored in XML format. So you can see the one example on the right. Go to the next slide. So now I've been talking about our progress. So for the information retrieval part, what we have done is to use we experimented with different language models to extract keywords from the question. And then we concatenate those keywords in a query and then send it to PubMed to get article that fits this criteria. The problem we have so far is sometimes we couldn't recognize the keywords in the question. So we are looking into improving our algorithms for keyword extraction, and we also plan to learn more about how to use the query for PubMed search engine more effectively. The last step is to build a vector database for the article that we retrieve. So for this competition, we have to return the top 10 most relevant articles for a question. And then it's usually the case that we retrieve a lot of articles from PubMed, and then we need to do more for text search in the abstracts of those articles to get the most relevant one. Yes, so next slide. For question answering part, we've been experimenting with different large language model, such as the Llama 2 and the Mixture. Also tried the model from different sizes. Currently, what we have is a few short examples with questions and answers. This helps us to prompt the LLM to get an answer that's in the correct format. But we haven't provided any context for the question in the prompt. So the problem right now is that since we didn't provide any context, any relevant snippets in the prompt, the LLM sometimes just make up the answers. So we have to think about ways to add more quality snippets in the prompt to improve the results. And also we want to try more advanced techniques such as train of thoughts or self-ask to get better results. And then we will combine with the vector database we're building in information retrieval portion to actually build a RAG system for this task. Next, so the most exciting thing is that we just submit the results of our baseline model to round 3 this week. And this is the submission page. We haven't got back the results, but this is a good progress that we made so far. That's all.
Awesome. Thank you very much, Wenshin. I'm super excited. That's probably the first submission from the group, so it's good work. Next, we have Touche. Is Ben on the call?
Yeah, I'm here, Anthony.
Excellent. All right, Ben, take it away.
Yeah, so my slides are relatively short, but we'll get through them. So for those of you who aren't aware of what the Touche competition is, our team specifically focused on task 3, which is image retrieval for arguments. So the Touche competition will supply you with a list of, say, 50 arguments. And then they also supply you with a list of images they got from a Google search. So the data set hasn't been released yet. We've actually emailed some of the competition committee and been like, hey, when can we expect this? They told us soon. But I think this year the data set's actually going to shrink to about 10,000 images. So that'll make kind of processing and storage a little bit easier because unzipped, because we're currently using last year's data set as like kind of like our testing for toy solutions and such. And I think unzipped, it's like 180 gigabytes. So making that smaller will be a lot more manageable. Since we're using last year's data set, we didn't do too much EDA modeling because that's not what we're actually going to be using. I've given you an example here of what you can kind of expect to see in this data set. So for example, the argument that this image would be applied to is, should nuclear waste be stored in old salt mines? And so they've given you the query used to put this into Google to retrieve it, which is illustration of environmental degradation from nuclear waste in salt mine, and also the rank applied to it. So you would, put that into Google search, and then this would be your 69th image. For the competition, you are evaluated on 3 different metrics, which would be how relevant the images you retrieved are. Is there an argument present in the image? Yes or no? And then did you get the stance correct? So for instance, like this image would be relevant. It wouldn't necessarily have an argument, and therefore it doesn't really have a stance. So you're evaluated on a precision at 10 images for each of the 3 metrics. So we're working through, getting a toy solution and kind of making a recommendation model. But if you go to the next slide, we can kind of detail our progress so far. So one of our team members, Elmo, has created a script that takes clip embeddings of both the text and the image features. So part of the data set that they provide you with is obviously the image itself. And in the most recent year, they've provided us with an OCR scan of the text on the image. And so Elmo's created these clip embeddings for both the text and image. And so we've kind of taken like a very small subset of images just to try and get, some sort of pre-processing pipeline built on these. Our goal with this for our next immediate step is to kind of create an attention network that kind of is able to apply the weights, text, and the image features. And we want to use this attention network to kind of train this contrastive loss, which is a loss function really typically used for recommendation and ranking and such, because contrastive loss allows you to find not only similar pairs between, for example, our argument and our image text features, but also dissimilar pairs. So that dissimilarity is going to be helpful for building out our solution. So that's been our main focus so far. That step in our process will be about retrieving the most relevant images to begin with. The next things that we want to do is obviously, once we've retrieved, the top 100 images, is to re-rank them onto the top 10 or so, and also create some sort of stance detection model, which, maybe all rolled into one architecture, maybe, you know, two-stage, three-stage model. Another interesting avenue we've been exploring is multimodal LLMs for like visual question answering. We've played around with this a little bit because some of them are very, very good. We've played with I think it was Optuna 7 billion parameter, where we can feed in an image and then tell us, hey, is this relevant to this argument? And initial results are promising. The only issue is that it's very, very compute intensive. And so we've been looking into methods to kind of shrink the model or compress it, you know, using pruning or knowledge distillation, but we haven't really delved too much into that yet. So hopefully we have an update on that for next month. If you go to the next, that's all for Touche. If you go to the next slide, we can get started on Pan. So I'm also leading the Pan group. I'll give a competition refresher, although I do want to say that I unfortunately lost a team member this week, Chinar. He had some prior commitments that he felt that he had too much time on his plate, and so he kind of needed to sort of selectively allocate his time. And so we wish him the best, but lost a team member on this group. So, but you know, back into what the competition is. This is a brand new competition. They haven't offered it before. The objective of the competition is to detect AI written text. So the competition committee really hasn't released too many details. Obviously, the data is not there yet, and there's practically no details on the website. We do know that this competition is cross-listed with the Eloquent competition, and so part of this is that the Eloquent teams will be building out AI written text data sets to be fed into Pan, where we will discriminate between real and machine written text. They've given us some high level overview of what we can expect of, like, they're going to be shortish texts on stock reports, sports, news, poetry, things like that. And so to kind of deal with this ambiguity, we've created not large, but maybe a few gigabytes text data set from Hugging Face and Wikipedia generated intros. And that's been our data set so far. It's been about 10 gigabytes. And so we've been kind of playing with, again, like a subsample just to kind of manipulate things a little more easily. But we've created some EDA scripts to kind of calculate simple statistics and visualizations about the data. We've implemented some simple baseline models that we got inspiration from Kaggle competitions. And currently we are focusing on researching perplexity measures and implementing a paper on factual coherence that we believe will help our solutions. So if you go to the next slide, we can kind of go more into that. So the baseline model, the two baseline models that we created was, the first one consisted of a TF-IDF vectorizer, which is term frequency inverse document frequency vectorizer, which basically creates this matrix of, you know, words that appear throughout your corpus. This creates a large matrix with a lot of columns. So we used PCA to reduce the dimensionality down, and finally fed that into XGBoost. It achieved pretty good accuracy, which was interesting because we also attempted to do something similar with BERT embeddings of the text. So we basically kind of took this sort of semantic meaning to the text, used BERT to, you know, create this summarization dimension, and also feed that in XGBoost. And we found that the results weren't quite as good as like the TF-IDF one. So that to us kind of signaled that word choice kind of plays a large part into the ability to discriminate between human and AI. So that was kind of our first run. Currently, we are implementing that paper. We've reached out to the authors of the paper to try and see if they have a code base they'd be willing to share, but radio silence. I mean, they published the paper 3-4 years ago. Basically, what the paper is about is it's neural deepfake detection on factual coherence based off of the entities in the text. So how it works is we parse out the named entities. So given a document, you tokenize the document into several sentences. each sentence is going to have several entities. So for example, like Jim is a software engineer, Jim, software engineer are both two entities. And then the next sentence might be he has a very large salary. So we're going to create edges, or you can kind of think of it as a graph is effectively what this is. You can kind of think of edges between Jim and software engineer. And then we also create inter-sentence edges between very similar entities between sentences. So for example, Jim and he would also have a very high kind of similarity score, which we use like cosine similarity. So we parse out these entities, we create Roberta embeddings from each word. And once we create the edges between each pair, our plan next is to kind of feed it into this GNN that sort of learns like the convolutions of each node to learn like these graph enhanced representations of each node. The paper includes like Wikipedia 2 VEC embeddings. We've skipped that part for now just because it was kind of a large lift to actually include that. But the GNN method looks promising, and we hope to kind of combine it with maybe some of these other maybe more word choice focused approaches. But that's it for Pan and Touche.
Awesome. Thank you, Ben. Yeah, that's great progress. There's some interesting findings, and some of the progress on re-implementing the paper for Pan seems super interesting. So great. Next we have IDPP, and so for this, I'd like to hand things over to Ritesh.
Thanks, Anthony. Hey guys, can you guys hear me fine? All right, perfect. So IDPP is another challenge in CLE 2024, and 3 of our folks, me, Alex, and Shashank, are going to be participating in it. You can go to the next slide. So IDPP basically stands for Intelligent Disease Progression Prediction. And just a quick refresher again on what are we doing here, why are we doing, and how are we planning to do it. So for the what part is we have to predict a score called ALSR FRS score. There is a full form for it on the screen. But basically, we have to predict this score given the sensor data from the patients. And this score is basically used to track the progress of disease, like the ALS or the multiple sclerosis diseases, which are basically neurological diseases. And these are chronic diseases, so they start very slow and then kind of progress. So this score essentially gives an idea of how the disease is progressing for a given patient. So that's our what that we're trying to predict that score. Why is the score important? As I mentioned, that it's important because it helps see how the disease is progressing, because every patient might have different progression rate. Some might be worse, some might be slower. But it's not all bad. It also helps in assessing treatment effectiveness. So if a patient is given a treatment and the score starts to improve, then that is a good measure saying that treatment is kind of being effective. So it's also used heavily in clinical trials. And how do we plan to do it? So this one, I mean, of course, we're all going to be using some sort of a machine learning technique. Currently, the score is calculated, and the reason we have to do this basically is also currently the score is calculated, it's kind of a hand calculated. There is a questionnaire that is given to the patients. Patients fill out the questionnaire with the questions in them, and a sum total of that is made, and that's basically the score that's given to the patient for that particular day. And this is, of course, very subjective. The questionnaire is yes, no types. No, score is very subjective. The question itself can be very subjective as well, that are given to the patients. So we want to see if we can use the sensor data in an objective manner and predict the score based on the sensor data. So and this becomes very cost effective. No patients, no doctors have to be involved and stuff like that. So there's a benefit to it. You can go to the next slide. Thanks. We don't have the data sets yet. As many of the other challenges, we have also reached out, and yeah, we haven't heard back yet. So we were told that we'll get it in early February. So we're hopefully expecting in next week or so. But while going through the data, we don't have the data sets, and since this is like a private type of data with privacy concerns because it's patient data. There is not much kind of data sets available online as well. So, but since it's going to be longitudinal data, we can kind of identify some of the challenges that we may face. Our data set is going to be very limited. It's going to be only 100 patients, and they are tracked over 18 months. And every 3 months, the score is given to them. So we have basically a mismatch frequency problem as well, where we have 3 months of data from the patient, but a score for only one score for every one of them, right? So collectively, over 100 patients, we have only 600 targets given to us, 600 target scores. That's basically it for us. So very limited data set and mismatch between the frequency are probably going to be our biggest challenges. Variable time intervals. Now, since these are sensor data, and it could be there will be variability in the time when the data is collected, versus also patient visits to the doctor for actually calculating their score would also be varying. So there will be time intervals that are going to be very variable over here. High dimensionality, because there is time points and they are measured in across multiple sensor data. And this is not just one sensor data. There are multiple sensors involved over here for speech, for limb functions, for respiratory functions. All of those the sensor data has to be combined and fusioned. So the data will be high dimensional. And since it's patients and different patients kind of have their own different body compositions, there are going to be fixed effects based on the age or baseline health, but there are random effects which are more notorious because that is very much patient specific, right? I mean, their body composition, measurement errors, and the unique rate of progression of a particular person because of its age or other conditions. So those have to be modeled as well. And of course, as I mentioned, this is a very subjective way of giving the score. So the target variable itself is very subjective to begin with, because it's been kind of handwritten by the doctors. And sensor data inherently brings noise with it. So we'll have to deal with that as well. So these are some of the challenges that we identified. Over our literature review, we found out some tools and techniques that we will probably want to employ. Cross-validation is one of the most important ones here. And it is not very regular cross-validation as any general data, because in general data sets, regular data sets that we have, all the variables are assumed to be independent of each other. They should not be highly correlated, basically. But in time series, it's a little different. The data set is very correlated because for a given patient, previous reading is very much correlated with the future reading. So we cannot just chop off any random shuffling here. We have to be very selective in our shuffling. Some of the methods that we have identified is splitting the data set based on patients rather than the times, right? So that way we don't have any future leakage, that we don't have to kind of accidentally look into the future and then try to predict the past, right? So we have to be selective there. And then there are some other ones that we found out in literature, like blocked CV, where we block certain time zones, some certain time series data, and only look at some other ones. And some of them are rolling origin, where we keep extending, for like we see for 3 months, then we extend for the next training set, we extend to 6 months, then we extend to 9 months. That way, kind of we build up our training set, adding 3 months of time in this case every time. And since we have very less data, we also looked into kind of trying to generate data synthetically. And interestingly, there are a lot of papers out there that do this, because longitudinal data is having a less number of less number of data points is a very standard problem across the industry, because patients come and go, they drop off, they start at weird times. So it's a very standard problem. So there are a lot of flavors of GANs and Bayesian networks and variational autoencoders that have been employed to kind of generate data. They kind of look at the existing data, and from there is more data that is generated. So we plan to look into those ones. And as far as the modeling goes, there is a lot of modelings that we saw across the board. People have used a lot of other stuff, primarily random forest, KNN, CNNs, RNN, the LSTM specifically in RNN is very popular, and a lot of regression models and even mixed effect models. So our thought process is to start with something like a linear or a mixed effect model in the beginning as a baseline model. Get the pipeline cleaned up, make a submission maybe in the first couple of weeks so that we can have a baseline. We know that our formats are right and all of that stuff. And then we can kind of go down to explore all these other models. And here are some links for our literature review and a presentation that Alex had done for feature-based time series analysis. And that's it from us. Thank you.
Awesome. Thank you, Ritesh.
Thank you.
Thank
Hey, can you reload the slides?
Yes.
Appreciate it.
How do I do this? F5. And then presenter view. It's right. Okay. So yeah, thanks, Ritesh.
I'm gonna talk
looking forward to the release of the IDPP dataset, and hopefully we'll have some interesting results to share next time.
Hopefully we'll have some EDA to share next time. Yeah.
And so next we'll have erisk, and for erisk, I'll pass things off to David.
Thank you. All right, so I'm gonna talk for a minute about what I'm doing right now. I'm handling task 1 right now. So basically, it's a series of documents that have the TREC format, which is a format that they use for information retrieval. It's essentially a type of XML format. So basically, what you need to do to read those files is just add an XML tag to each one of the files, and that usually does it. But I also encountered some problems. Some of the files have like floating characters that you have to deal with, or they have like non-printable characters that you have to remove. So after doing that, which is part of the pre-processing, I was able to convert the files into Parquet, which is a binary format that's faster. And then after that, I just merged them together into one file. After doing all of that, I finally I launched up a Jupyter Lab instance in my personal computer, and I just did like a quick checkup of what was in there, and that's what you can see in the slide. It's just basically a collection of texts. They're basically posts from Reddit, and the pre and post are like the text that accompany that specific post. I guess they added for context. So maybe you can use that to do more analysis. We have 15 million, 15.5 million posts right there. And I think the file was like around 2 gigs. So it was like pretty big even for my computer, like to handle. So yeah, that's basically what I'm working on right now. I'm gonna pass it over to Aryan. He's a member of the team, and he's in charge of task 2, I believe. I think. Okay, go ahead.
Yeah, thank you so much. I'm Aryan. I'm working on task 3 for erisk. The task 3 caters to measuring the severity and signs of eating disorders in various Reddit users. The input data set is essentially XML files that corresponds to each user. It's a thread of Reddit posts and Reddit comments made by the user, and the task is to use this data as an input and then use that to answer a questionnaire which is based on eating disorders and essentially predict a state of eating disorders for each of the users. The data set is pretty limited. It's divided into 2 parts. There's a folder for 2022 which contains roughly 25 to 30 users. So 25 to 30 XML files containing comments and posts made by these users and their Reddit threads. And 2023, which has roughly 40 to 45 XML files, again corresponding to 40 to 45 users. Over the last week, we created an XML parsing script which converts the data in XML files held in XML tags into JSON files, which can then be used as an input for the models that we create in the future. I was also able to conduct some basic EDA. This includes just standard character counts, word counts, mean sentence lengths, and stuff like that. There's one example that you can see on the screen. You can go to the next slide. We also did some n-gram analysis, seeing which were like common bigrams and common trigrams in the 2022 and 2023 data sets which are available. And as you can see, most of the words tend to have like a negative connotation or like a negative semantics to them, which hints towards like eating disorders. The next slide has the same commonly occurring bigrams for 2023, and words such as eating disorder seem to commonly appear in most user text and user posts and responses on Reddit. The next step that I'll be taking for task 3, would you can go to the previous slide, sorry. Yeah, the next step that I'll be taking for task 3, one will be to just sort of clean up the parsing script that we have, because I feel like it's not able to read certain characters or certain emojis correctly, figure out a way to parse those and maybe even encode them in the future. And since essentially task 3 is basically a question answer problem, we'll look into models such as BERT and Inference by Facebook, which have already specialized in question answering, and maybe something like a sentence selector model, which can sort of focus on converting sentences into vectorized outputs that could basically hold some sort of semantic representations and then use that to fill up the survey or questionnaire that they have provided. We've also been provided with a ground truth, which is the actual user responses for each of the questionnaires, which we will use to sort of compare and check the efficacy of our model.
Great.
Yeah,
I
thank you.
assume that's the end of the updates for erisk. So thanks, David. Thanks, Aaron. I'm glad you're able to get through the pre-processing step of reading those XML files. It's a little gross to have to deal with XML. So for our next presentation and our last update, I'd like to pass it to Joshua to tell us a little bit about longeval.
Hi, everyone. So we only recently got started last week, so we're a little bit behind the curve, but we're catching up really fast. So the first task is developing a more traditional information retrieval system, and we're evaluating its temporal persistence, meaning, how well does it do retrieving relevant documents and relevant information over a longer period of time. So right now we're at the stage of uploading training data to GCP, investigating, can we use Apache Spark for data pre-processing, and researching the Lucene library, Apache Lucene, for developing the key components. The pre-processing and exploratory data analysis phase. Can you go to the next slide? Thank you. So they're essentially these two components, which is the parser and then the analyzer. And so we're going to be using Java to do this instead of using Python, which is fun. I'm going through the data structures seminar and working with Java, so we're going to be best friends for this project. But essentially, we're extending the methods of the Apache Lucene library to start performing these tasks, these first pre-processing and exploratory data analysis tasks. Right now, we're just about done with implementing the parser module, and we're going to be running. I'm going to start running trials to make sure it actually works, hopefully this weekend. And then the other part of that, basically the parser just extracts the information from the actual documents in the correct format. And then the analyzer will actually do all the pre-processing, doing tokenizing, stemming, filtering different filtering the LSNs out and stuff like that. So task 2 is more of a machine learning NLP task. We're implementing a sentiment analyst binary classifier that is supposed to be temporal persistent. Again, really just trying to make sure that there's not a huge drop off in performance while we're after 6 months, 7 months. So we've updated the training data to GCP buckets. We're actually at the point where we're using Apache Spark for data pre-processing. This one will be in Python. Next slide, please. So currently we have been using the NLTK library, the usual NLP library for the cleaning of data, removing rare words, and performing tokenization and stemming. After the initial EDA, we realized that they had done a lot of the work for us as far as cleaning the data. URLs were removed, links, emojis, emoticons. They already had removed duplicates and near duplicates. So now we're kind of in the portion, we're a little bit farther ahead with this second task. So the future considerations about this data is that the usual pre-processing and labeling isn't necessarily going to work because we don't want to overfit for we don't want to longitudinal overfit for right now and then turn around and the model can't recognize the different sentiments. So it's a really interesting problem. We're probably going to be using semi-supervised and unsupervised models, because even though they're not as precise as the supervised models right now, they don't rely as much on the labels that you create. We're also looking at employing deterministic optimization, to optimize the algorithm that we're using within the model. For our baseline model, we're looking at some pre-trained baseline models to kind of benchmark our competition models. We're looking at having about 2 to 3 core competition models to kind of test and see, what approach works the best for this task, since we're really looking for which approach can last over 6 months, and we don't have to retrain it on new data. So yeah, that's about it.
Great. Thank you, Joshua. I'm really looking forward to seeing what the progress is going to be like on longeval. I find traditional information retrieval things super interesting. And you asked whether Spark can be useful. The answer is yes. So we can talk. So with that, we have all of the 11 teams present. So hopefully that was a good selection of different domains, and it was interesting to me to see how progress has been between different teams. I think we're on a good pace, and I'm really excited for what everyone will have for next meeting. So next meeting is going to be taking place on the second Thursday of the month, and so that happens to fall on Pi Day. And this meeting will be focused on modeling. So you should be, at this point, you should have your first submission to the competition if it's open. You should try to find the shortest path between your data and a submission on the leaderboard, and from there you're able to kind of climb up as you iterate and figure out what works and what doesn't. So that is hopefully a goal that everyone shares, like having a submission and doing a little bit of research into what the final solution might look like. We basically have 2 months left before the competition is done. We have March, April, and then beginning of May is generally when the competition closes. You'll have a couple weeks to write up your working notes, and then they'll go through the review process and so forth. So there's not all that much time. So make sure that you're budgeting time correctly, that you have a rough timeline of things, and that you're having fun. So with that, are there any questions from the room?
I have a quick question regarding the timeline.
Yeah.
So as we have seen, like many of the competitions do not have a data set released yet. So like uh, typically like from previous years, how much time is usually given between like the data set release and the final solution? Because we only have 2 months, right? So
Yeah.
it's time.
It really depends from lab to lab. Some of them will have the competition open in like November or December. Some of them won't open until like March or even April. I think bioasq has a one that starts running in April. But it is generally fair because all the other teams are also they also have to wait for the data to be released. So everyone is on a relatively equal playing field. If they've been in the competition before, then they might have some code that they can use to kind of jump ahead. But everyone has to deal with like the lack of competition being open. Yeah. I'd say 2 months though, like 10 weeks is probably like enough to build a model, build something that might work and that has some novelty. So
Okay, thanks.
any other questions, comments, concerns? Cool. So with this, it's been an hour and 20 minutes or so. So I'm glad that we extended the meeting by 30 minutes to have the time to budget. Yeah, I think we had a really productive meeting today. I'm really excited for the next milestone presentations. And until then, thank you very much. Let me stop recording too.